Hi, I'm JB Baker with ScaleFlux here at SuperCompute 19 in the Xilinx booth. We're demonstrating our latest generation of computational storage drive, the CSD 2000. It utilizes a Xilinx Kintex FPGA as our processor for both our flash management and our computational storage services. The computational storage services that we're highlighting here are an inline compression decompression engine and database query offload or database acceleration. With the compression decompression engine, we're able to do two key things. One is improve your performance, and then two is improve your costs. How do we improve the cost? Well, we take a drive that would ordinarily be configured to 3.2 terabytes, 4 terabytes of raw NAND, set to 3.2 of user capacity. And we're able to configure that up to 6.4 terabytes of user capacity, and through our compression engine, we compress the data as it is written to the drive, and as the data is compressed, we expose that extra free space back to the user. And that's what we're demonstrating or showing in our demo here. The other aspect of that inline compression decompression is a performance acceleration and a latency improvement. So with just standard FIO runs and looking at IOPS, with a traditional NVMe drive or any SSD, as you run from 100% reads down into 100% writes, you see a very rapid drop off in performance once you mix in writes to the equation. With our compression decompression engine, we're able to maintain a very high level of mixed workload and read write, so we're up to 2x the competition in terms of performance in those mixed workloads. Now for application benefits, that translates into better latency. And so what we show in our slides here and through our performance testing benchmarking on Aerospike, for example, where they run a specific workload, a specific pressure test of 2-to-1 reads to writes, and a certain number of IOs that you're trying to run through this drive over a 24-hour period. If you exceed 5% of transactions exceeding 5 milliseconds or 1 millisecond over any 1 hour period, you fail the test. And what we're able to do is show that not only are we lowest at any given workload, but we're able to pass at the highest workload of any NVMe SSD. So moving on to the database acceleration aspect, or database acceleration feature, we're able to offload some of the query processing down to the drive so that we reduce the burden on the host CPU, reduce how much data has to get moved to the host, which frees up memory bandwidth and memory space as well. The two tests that we've set up here are one, a scaling of the number of instances of a RocksDB from 1 to 8, each with a 100 gigabyte database. And as you scale with the ScaleFlux drive, you're able to maintain very consistent performance here. So down around the 500 seconds to complete the task. With CPU only, without offloading any of the tasks to the drive, you hit about 4 instances, and now the CPU has become 100% utilized, and your latency starts to spike up. The query time just goes through the roof, because now the queries just have to line up and wait for others to finish. The second demo that we show is running analytical processes at the same time as you're running transactional or updates to your transactional database. Ordinarily, as soon as you start adding those analytical queries, your database is going to slow down. That's what we show with the gray line. Again, you're overburdening the CPU, you're filling up the host memory bandwidth and filling up host memory, and so the database just bogs down. By offloading some of the tasks to the SSD, we're able to keep the performance very, very high. You see in the purple line that the transactions per second maintains very high, even as we add 2, 4, 6, 8, 32 analytical processes running on top of the database at the same time. So great that we improve performance, but it also improves cost, because a lot of times what people will do is they put a second copy of the database there so they can run the analytics against that copy while they're running transactions against the original copy. So we cut your infrastructure cost in half once again there. So that's the CSD 2000, again highlighting here at SC19 in the Xilinx booth. We're very thankful to Xilinx for having us in the booth and for having such a great FPGA to work with. Thanks.